Hello, my name is Phil Root, and I am chemistry faculty at Scottsdale Community College, where I'm also the Open Educational Resources faculty specialist there. And welcome to my showcase about how we utilize open educational resources in our redesign of our chemistry curriculum at SEC. Just to give you some background and highlight some of the work in collaboration we've done, we started in around 2017, 2018, working on redesigning our Chemistry 130, our Intro Chem program. That was done with faculty at SEC, also in collaboration with faculty at Estrella Mountain Community College. And in 2019, we started focusing more on the Chem 151 and 152 programs, the general chemistry. And of course, that went a little haywire in spring of 2020 with the onset of the pandemic. And since then, I would say we've been doing our best to kind of hang on. And thankfully, we've been supported with our use of open educational resources. That's made the kind of emergency interim a little bit easier to keep supporting our students and helping them learn. So I wanted to give you guys a little bit of background in terms of how that curriculum development kind of what that centers on. So I will share my screen at this time. And the curriculum is based on a sort of a modeling cycle in which we build scientific models rather than focus on chapters or individual discrete topics. How that starts is generally with a paradigm experience, some type of demonstration, or usually a lab experience at the start of the week per se. And for example, here, if we wanted to start looking at reactions in stoichiometry, we might start with investigating yield, measuring masses, measuring products, looking at reactions of baking soda with either hydrochloric acid, any other acid, or thermal decomposition, and making appropriate measurements. From that, we would have a post-lab discussion about our results, what our results tell us about reactions, and the ability to make measurements and make predictions. And we would enter the model development phase, kind of developing a model of how we might keep track of reactions. And so for that, we usually do that through in-class discussions and activities that follow up the lab. Here we have a particle representation of another reaction, followed up with development of an idea of a before change after table to keep track. And so we kind of teach these tools and develop the model of chemical change in the context of what we observed in the lab. After developing the model, we deploy the model with either practice problems or worksheets, where the students are involved. This is kind of they're on their own time. For homework, they see if they can use the model effectively. Scroll back at the top here. So again, there's a worksheet with a particle diagram, some qualitative conceptual questions, and some more traditional quantitative predictions using the tools we developed. You might note at the top of some of these, we have some links, and usually to OpenStax or some supplemental readings that we've worked to develop. So one of the main open educational resources that we do use in support of our curriculum is OpenStax. So for example, one of the best things about OpenStax is you've got the electronic version is fantastic. You can click on whatever link you want to go to that section. And that section loads up, and you could take a look at the different examples, the different objectives for that. And the students can use this after we've discussed the ideas in class to see maybe a different perspective or see some additional example problems. One of the nice things about it is it also contains exercises so the students can get additional practice. And much like a traditional textbook, the answers are quote unquote in the back, but you can just click directly on the blue links, and students can check their work and get that immediate feedback. So this is out of the OpenStax project from Rice University. We found it to be a great resource. I've been using it for, around 8 years now, I think, from the first edition now into the second edition. One of the other resources that we use in our curriculum for open educational resources is PhET. PhET is an interactive simulation program out of the University of Colorado Boulder. And there are many physics, chemistry, they're working on other areas as well. And many of the simulations are now HTML5, so they can be run from the desktop, from the browser. Many of the simulations can also be downloaded so the students can keep them in perpetuity, as we would want for an open educational resource. So an example of that, the students could be directed to this game reactants, products, and leftovers. If we go back to the home page, there's kind of a real-world example, molecules, and even a little game. So they could practice, again, kind of connecting the particle representation to the numbers in the balanced chemical equation and checking their understanding there. And there's even a little game they can play with tiered levels of difficulty. So that's kind of what we have now. And for looking towards the future, we're looking to refine our activities more once we get back to in-person and we can study efficacy a little bit better and continue to work on collaborating a little bit more and not just survival mode and trying to give our students the best experience right now. So looking to do that. We'll also look to further our lab development. Right now, we basically use labs that are pretty typical labs. The main shift is it's not really a flipped classroom, but we flip the order of the lab. We put the lab up front as the paradigm experience rather than a verification experience. And so we tried to write the labs that are common use, but we just write them ourselves, and that way we can openly license those. And there's some good work going on at Stray Mountain on that right now. And we'd also like to work on modifying the OpenStax chemistry text to follow the development of the scientific models rather than the more traditional order, but using that support material. And we're looking to do that with the current version of Pressbooks that Maricopa now has, ModPress. So those are kind of some of the goals of the project. So I look forward to connecting with anyone interested in discussing what we've done and what's worked, what's been a struggle during our this OER Arizona conference. Please join the conversation, contribute to the Padlet. I can be contacted at any time. My email is philip.root@scottsdalecc.edu. If you're in Maricopa, you should be able to type in the first few letters and that comes up. Again, that's Philip, Philip, .root, ROOT, like under a tree, @scottsdalecc.edu. Thanks for your time, for taking a look at this, and I hope to discuss further with you in the upcoming conference. Have a great day.